Part 2. Right triangle trigonometry.
Now that we know what angles are and how to measure them, we can start looking at triangles. A triangle is a closed figure with 3 sides and 3 angles. Remember, we're only looking at planar or flat triangles, and they always have straight sides. We're going to start by looking at right triangles.
A right triangle is one which contains a right angle. Remember, a right angle measures 90 degrees, or pi over 2 radians. There can never be more than one right angle in a plane triangle, because they're kind of insecure and they would get jealous of each other and fight like cats and dogs.
Aww, that's so cute!
We're going to draw a triangle and talk about the individual parts that make up that triangle. First, we'll draw an acute angle. An acute angle is one that measures between 0 and 90 degrees.
Angles are usually named using lowercase Greek letters such as alpha, beta, gamma, or theta.
We use Greek letters because early Greek sailors were the first to use trigonometry. Each generation learned from the ones before, and no one bothered to change the names.
Hey, we've been using the same Greek letters for a while, so how about we change them to Pig Latin?
Yeah, maybe.
So let's go back to our triangle that has an acute angle in standard position. Remember, an angle's in standard position when its vertex is located at the origin of a coordinate graph, and its initial side coincides with the positive x-axis. Here's the terminal side of our acute angle alpha. Now pick a point on the terminal side.
We'll pick a point here on the terminal side and call it point P. Now we'll draw a straight line down to the initial side of angle alpha so that it intersects with the initial side perpendicularly. The right angle has been formed where the line from point P intersects with the initial side of angle alpha. We have a right triangle. Pretty nifty, huh?
We'll name some more parts of this right triangle to make it easier to talk about.
The 2 sides that make up a right angle are often called legs.
We'll call the legs that make up this right angle A and B. The last side we'll label C. This side is called the hypotenuse.
The hypotenuse of any right triangle is always the side opposite the right angle. It's conventional to make the side opposite an angle the same letter as its Greek counterpart. You can see that side A is opposite angle alpha, and side B is opposite angle beta.
And that's it for parts of a right triangle.
Section A, the Pythagorean theorem.
Now that we've named all the parts of a right triangle, we need to figure out the values of all the parts of this triangle. First, we'll talk about how to find the value of the sides. Luckily, the Greek philosopher Pythagoras came up with a theorem to help us do just that. The theorem states that the square of the hypotenuse is equal to the sum of the squares of the other 2 legs. Okay, that was a mouthful.
The Pythagorean theorem lets you figure out the values of the sides of a triangle.
The formula is a squared plus b squared equals c squared. C always represents the hypotenuse of a triangle. Remember, you can make A and B any side you want, since it really doesn't matter when you're using the Pythagorean theorem, and the angles haven't been named yet in the triangle. Legs A and B perform the same way in the theorem, but the hypotenuse is always labeled C.
Let's do a quick example in which we'll have to use the Pythagorean theorem.
Here's a triangle, and we don't know the hypotenuse, but we know the sides, so we could use that theorem and it'll all be done.
Let's try that again. Yeah, let's try that again.
For this triangle, we know the value of side A is 3, and side B is 4. We don't know the value of side C. Since we do know 2 sides, we can use the theorem to find the length of the hypotenuse, side C.
Remember, the formula for the sides of a right triangle is a squared plus b squared equals c squared. Plugging in the 2 known sides, a and b, we get 3 squared plus 4 squared is equal to c squared. Now you just need to square the numbers to get c squared is equal to 9 plus 16, or 25. We take the square root of both sides to get c is equal to 5. We now know the values of all the sides of the right triangle. Grand, ain't it?
The Pythagorean theorem is a vital tool to have in order to figure out the values of a right triangle. Go! Oh, funny bone! Oh.
Okay, quick. Who remembers what the definition of trig is?
It's the study of the relationships between the angles and sides of a triangle.
Right. And the Pythagorean theorem is one of the ways to find those relationships. But it can only tell us about the sides of a triangle, and we want to find the values of all the parts of a triangle. I mean, who doesn't?
Me. I don't.
The trig functions we'll be looking at next will show us how the values of the sides can help us find the values of the angles in a triangle.
Oi, Section B, 6 trig functions. Oh, good.
Functions? They don't have any. That's their whole problem. Why,
Actually, they have a very important function. The trig functions are the ratios of different sides of a triangle with respect to an angle. So let's say you have the sides. With trig functions, you could
determine the angles of a triangle, get a really good grade, run for president, and change the time zones.
With trig functions, you only need to know the values of the sides to find the measure of an angle. Remember, our goal is to figure out the values of all the parts of a triangle, and trig functions are handy little gadgets to help us out.
You're all fixed up now, honey.
That's right. There are 6 basic trig functions: the sine, the cosine, the tangent, the cosecant, the secant, and the cotangent. Like she said, these 6 trig functions are defined by the sides of a triangle and the angle being measured.
Look at this right triangle with theta as one of the acute angles. Here, theta could represent alpha or beta from the previous triangle. OPP represents the side opposite theta. ADJ represents the side adjacent to theta, and HYP stands for the hypotenuse.
So the 6 trig functions for theta are defined like this. The sine of theta, abbreviated SIN, is the opposite side from theta over the hypotenuse. The cosine of theta, abbreviated COS, is the adjacent side of theta over the hypotenuse. The tangent of theta, or TAN, is the opposite side over the adjacent side of theta.
Now the other 3 functions. The cosecant of theta, shortened to CSC, is the hypotenuse over the opposite side. The secant of theta, or SEC, is the hypotenuse over the adjacent side. And finally, the cotangent of theta, or COT, is the adjacent side over the opposite side.
A good way to remember the first 3 trig functions is SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So if you're trying to remember your trig functions, think of warm water on your toes.